Hello again! Now we have to design properly our system from the mechanical point of view. To do it, Easy Shape Designer is now available as a new feature of RDNet 3.1. It allows to design and get in few clicks all the data we'll need to set up the clusters, angles, pickup points and cluster safety factor as well. We are going to work in our outdoor demo area with an 8+8 HDL30A line array in combination with 8 subs 9006 AS in end-fire configuration. Go to the Easy Shape Designer drop-down menu and select New. First, double-click in the name of the venue and give a proper name. Let's type Main. Then, select the model we are working with, HDL30A in this case, and the number of modules, 8. And press Create to build the cluster. Now we have to input the data about listener 8, in this case stand up, so 1.7 meters, audience area starting at 7 meters far from the stage to 65 meters. If necessary, we can add a second audience area as balcony or bleachers. For example, starting at 75 to 80 with an 8 of 3 meters. You can also change the dimension of the area by dragging directly with the mouse in this way. In our case, we don't have a second audience, so let's unflag the option and keep the 8s at 0. Now we have to set the temperature and humidity, because this will affect the HF preset that will be applied at the modules. Very important. This will make big changes in the equalization and will ensure a really constant frequency response along the audience area. Today we have 3 degrees Celsius with 50% of humidity. Type also the 8 of the flybar and number of pickup points. Of course, with one pickup, as in our case, the cluster will automatically take the right tilting according with the hole in which we'll fix the shackle. Working with 2 pickups, you have to adjust the inclination with the engines, looking at the internal inclinometer value in the first box, which has always the same inclination of the flybar. By pressing Auto's Play, we'll get all the data we need and the basic representation of the cluster with the aiming of the modules. In the load and distances field, we can see the total weight of the cluster and the hanging data. These numbers are related to the holes in which we have to fix the pickup on the flybar. The first letter is related to the direction of the pickup. It can be A with the smoothest part facing the back, or B with the smoothest part facing the front. The second letter is related to the big pickup holes and can be F front, C center, R rear. These data are graphically represented here, where you can easily see the pin position and orientation of the pickup. There is also the last speaker distance from the ground, so with the laser meter we can be sure to achieve the right 8 of the clusters. In this field we see the angles we have to set among the modules, and here the HF correction that will be applied individually to each module according with the design, temperature and humidity. Be sure to set the system according with this data. Talking about the subs, they will be placed in the center between the 2 clusters, close together on the horizontal plane in 2 rows composed of 4 subs each, about 1.5 meters spaced front to back. That's all for the design. Let's go on the field to fly the cluster and place the subs as well. See you later. Bye bye.